They have to read my lips. So anyway, as this is starting out wonderfully, this is activity 1-2 in SpringBoard Algebra 1. Let's start off where we left off, number 11. Starting off where we ended off, number 11. It says graph the data from the table on the appropriate grid. So we need to make sure that we graph it. Right? That's the first thing. And then we need to make sure that we label the scales on the y-axis. That's the second thing. So I don't have to do all the flipping back and forth. Let me go ahead and write my table. The X stood for the figure number, right? So my X stood for the figure number, and that would be 1, 2, 3, 4, 5, 6, 7. My Y stands for the outer squares. And we said for the first one, looking back at like number, what was that, number 7? 12, 16, 20, 24, 28, 32, 36. Okay? So now we need to graph these. Well, before we can graph them, we have to make sure we have an appropriate scale. We have to make sure that our numbers are where they need to be. Okay? We know this starts at 0. Both of these are 0, right? This is 0, 0. And this goes up 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 units to work with, and we can scale it to whatever meets our needs. So what you do is you take whatever your largest number is. For us, you see here it's 36. And we'll say, well, 36 divided by 9 is 4. So in order for me to be able to fit all of my stuff on here, I have to go by a scale of 4. So from 0, I go to 4, 8, 12, 16, 20, 24, 28, 32, 36. Okay? And so that is my scale. And so now whenever I graph this, I just go and find 112. Well, 112 is there. 216 is there. Then I go to 320, 424, 528, 632, and 736. And that one would be right there. Okay. And we got to this, just as a reminder, we got to this because, again, we let n equal x, right? N is going to equal x. And we said that our y was the product of our first term. Remember, this is our sequence. Sorry, I misspelled sequence. That's an E. Sequence expression. Right? Sequence expression. Our sequence expression of first term plus the common difference n minus 1. First term plus the common difference n minus 1. So our first term here was 12. Our common difference was 4, n minus 1. All right, and that's how we came up with this. So for B, right, for graph B, we said that the figure number, right, which was our n, right, that's our ultimate, our x and our y, but we said the figure number, which was n. And how did we come up with our expression? Do we remember what we said? We said at number 8. What did we say the answer was to number 8?
The number in column 3 are the squares of column 1.
Yeah, the numbers in column 3 are the squares of column 1. So we got, if column 1 is n, we get that by saying n squared. Okay? If our figure numbers are n, then we get the result by saying n squared, right? So we said if the figure number was 1, 1 times 1 is 1. Figure number is 2. 2 times 2 is 4. 3. 3 times 3 is 9. 4, that's 16. 5, that's 25. 6, that's 36. 7, that is 40. That's 40. Let me erase that. That is 49. Okay, that's 49. So now we have to take our 49 divided by 9, right? Because again, this is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that doesn't give me a whole number, right? That gives me 5 point something, right? 5 point something. So can my scale be 5? No, because if it's 5, will it fit? No, not everything will fit. So I got to use my next whole number up. Here's the reason why. If I say 9 times 5, that's 45. If I say 9 times 6, that is 54. Well, 54 is larger, so that means I need to use a scale of 6s. Okay? Scale of 6s. So that would be 6, 12, 18, 24, 30, 36, 42, 48, 54. Now, if your scale was anything larger than 6, let's say you used a 7 or an 8, it's still fine. Your graph is just going to be a little bit more condensed. Okay? But if you use like 1, 2, 3, 4, or 5 as your scale, that would be wrong. So if you go a little larger, that's okay, but you can't go smaller. All right, let's graph this out. We have 1, 1, that's going to be about right there. 2, 4, that's going to be about right there. 3, 9. 4, 16. 25. 36, okay, that's a good bingo. So I know where that one's going to be. That's going to be right here on this crosshair. And then 49 will be right there. Okay. Number 12. Number 12 asks us to compare the graphs. So compare graph A to graph B. Compare graph A to graph B.
Do you know what I'm talking about?
No, I don't think you know what you're talking about.
Oh, yeah.
Look at the graphs. We're just looking at the graphs. Look at the graphs, right? Look at the graphs. Look at the red dots. Look at the blue dots. Compare them. One's straight, the other's curved. Okay?
Chart B increases more than chart A.
All right, so kind of your understanding of that does need to kind of change just a little bit because whenever we kind of go through these, yeah, I mean, these are, like I said, line graphs. But the thing is that you need to make sure that in algebra, we identify a line. When I tell you something is a line in algebra, it is a straight line. A curve is a curve. It's not a curved line. A curve is a curve. A line is a straight line. So A is a line. B is not. So that's all I got to put. So I'm going to number 12. And I'm going to say graph A is a line and graph B is not. Use the pattern you described to predict the number of intercolored squares to the 10th figure pattern. All right, so the pattern that we discovered in number 8 says that the numbers in column 3 are squares of the column, the numbers in column 1. That's the pattern we discovered, right? So we talked about it again, that the pattern we discovered is that, let me exit out of that. The pattern that we discovered, right, is that our figure number, right, our figure number equals n, and n squared is the, all right, is the expression. That's the pattern. That's what we noticed. Okay? So what figure number are we looking for? We're looking for 10. So we're going to say n is 10. And if n is 10, then n squared is 10 squared, which that's just 10 times 10, which is 100. That's just 10 times 10, which is 100. How is the number of inner squares related to the figure number? That's just putting into words what we've been doing. It is the figure number squared. Right, we're just putting into play what we've been saying. It's the figure number squared. Use the variable n to represent. Well, we've already done that, right? That's going to be n squared. Or if you write it, that's going to be n squared. It would look like that if you write it. Use your expression to determine the 17th figure. So n is 17. N squared is what we're doing. So that is 17 squared, which is the same as 17 times 17, which 17 times 17, 9, 4, 1, 2, 3, 4. So that'd be 19. And then 1, 7. That's 2, 8, 9. 289. That would be 289. So Myzine discovered another pattern in the artifacts. He noticed that the triangles were used. The triangles were all equilateral. That's a vocabulary word. Equilateral and often multicolored. All right, equilateral triangle, that just simply means that all three sides have the same measure. We know that equal, right? EQUI means equal, right? So equilateral means that they are all the same lengths. Okay, again, this is a vocabulary term. So they are all the same lengths. All right, so that's kind of important there. That is a vocabulary term. So that is important. So it says all of these are the same length. It says determine the perimeter. Determine the perimeter. Determine the perimeter of each figure in a pattern if each side of one triangle measures 1 centimeter. Perimeter. What does perimeter mean? When we talk about perimeter, what does that mean? What do we do? Huh? No, length times width. That's usually how we find area. How do we find perimeter? Just use your words. How do we find perimeter? We don't find perimeter by using the area. The area is the area. The perimeter is the perimeter. What do we do to find the perimeter? You add all the numbers. You add all the sides. Okay? You add all of the exterior sides. So we need to write that down, right? So how do we find perimeter? You add the exterior sides together. You add the exterior sides together, right? So you add all the sides up. So this says that this figure here, that this triangle is one side from here to here. That one side is 1. So from here to here, that one side is 1. And then from here to here, that one side is 1. So to find the perimeter for figure 1, I add all the sides up. 1 plus 1 plus 1. And what do I get? 3 centimeters. All right? I get 3 centimeters. Well, let's take a look here. So from here to here, right? Let me use red so it sticks out a little better. From here to here, that's 1. From there to there, that's 1. From there to there, that's 1. Right, that's 1. Right. From here to here, that's 1. From here to here, that's 1. Do I count the ones on the inside? No. The area is the exterior. It wants to know the outside. When we have to know something about the inside, that's usually the area. Okay? So figure 2 is 1, 2, 3, 4, 5. 5 centimeters. All right. Figure 3, from there to there is 1. From there to there is 1. 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 And to there is 1. 1, 2, 3, 4, 5, 6, 7. 7 centimeters. Okay, so whenever I finish that up, I flip the page, and now they want me to create a table. Meising found that he could determine the perimeter of any figure in the pattern using the expression 2n plus 1. 2n plus 1. All right, 2n plus 1. I'll write that up over here. 2n plus 1. Meising's expression to calculate the perimeters of the next 3 figures in the pattern. Use the table to basically go from there. So we know figure 1, right? We know figure 1 is is 3. We know 2 is 5. We know 3 is 7. We see a pattern already, right? This is plus 2, plus 2. But they give us an expression, so let's utilize that, right? We're going to let our figure numbers be in, and we're going to say, well, what about 4? So 2 times 4, which is 8, plus 1, which is 9. And does that match our pattern? Yes. If I say this is 9, does that match our pattern of this being plus 2? Yes. Yeah, it does, right? All right. And you're wondering, Mr. Lemons, where did he get the 2n plus 1? Well, he did the same thing we did. You take the first term, which is 3, plus the common difference, which is 2, n minus 1. Okay? But what he did is that he went on and distributed the 2 to get 2n. He distributed the 2 to negative 1 to get a negative 2. Added the 3 and got 2n plus 1. Okay? So the expression that we've been getting, which would have been here, and his expression is the exact same thing. He just went on and simplified it a little bit, okay? And I ask you, wait till you get your figure number to then simplify. That's all. So number 5, it would be 11. 6 would be 13. 7 would be 15. All right, what's the sequence? Write down the sequence. This isn't stuff you need me for. Go ahead and write down the sequence. You don't need to be looking up here to see how to do it. This is stuff you should know by now. What's the sequence? Write down the sequence. Okay, here's what the sequence is. And 15 is as far as I go. Can it continue? Yes. ... Does it have a common difference? If so, identify it. Okay, so we'll move this up some. So does it have a common difference? Yes, it does. The common difference is 2. Why do I write the common differences 2? So that way whoever's grading my paper knows that I know the common difference is 2. I don't want them thinking that I think the sequence is 2. I don't want them thinking that does it have a common difference? That the answer to that question is 2, Mr. Quinney. All right. Mr. Quinney is asleep if you're watching on YouTube. Mr. Quinney is dead asleep. All right. So you have to label it. Label what it is. All right. Get off my wall, please. All right. You have to label what it is. You have to label what it is. Now it's asking you to represent it by drawing a graph. All right. Represent it by drawing a graph. So it wants us to graph it. It wants us to label our axes and make sure that to scale the y-axis. Okay. So what is our x-axis stand for? We go back up here, right? Here's our x's, right? And that's our y. So we know the figure number is my x. So my figure number the perimeter is my y, right? The perimeter is my y, and that is in centimeters. I need to put my unit. The perimeter is in centimeters. Now I need to label my axes, right? My biggest number is a 15, and I got to go 9 spaces, right? 15, 9, that's 1 point something. And so that means I need to go by a scale of 2, right? Because 9 times 1 is 9. 9 times 2 is 18. And so 18 will cover 15. So I need to go by a scale of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay? Now, you can't start like a number 1 and then a number 3, number 5, number 7. You can't do that, okay? All right, Mr. Quinney, do you need to stand up? Hey, can you stand up for me? I want you to wake up, okay? I need you to pay attention. All right. No, you're about to fall out the desk, okay? All right. And that would make me go viral on YouTube, but I can't do that, right? It's got to look at me. So 2, you can't say 1 and then skip to 3, 5, that. If your scale is 1, it's got to stay 1. If your scale is 2, it's got to stay 2. Okay? So you can't just say, well, I'm going to make it a 1 and then 3, 5. That way it looks good. You can't do that because from 0 to 1, the scale is 1. Then from 1 to 3, the scale is 2. You have to have the same scale. So I'm going to go through, I'm going to graph this looking at number 18. I got 1, 3. That goes there. 2, 5. That goes there. 3, 7. That goes there. 4, 9. That goes there. 5, 11. That goes there. 6, 13. That goes there. And 7, 15 goes there. All right. I need you. We have a few minutes left. Well, let's go ahead and I want you to start working on 21 through 25. All right. I'm gonna give you literally a minute, and then so that way you start working on it. I don't want to see your eyes popping up to the screen because I'm gonna go ahead and work out the answers. Okay, so that way you can check them once you have them. Mr. JJ, I do not need you cheating, sir. Called him out on YouTube. Okay. Go ahead and start 21 through 25, and I'm going to work them on here, and then I will put the, like I said, and then you, whenever you finish with them, you can check your answers. Okay? All right. So to the 10th figure. All right. So that would be starting out at the 6th figure. That's 14, 16, 18, 20, 22. So that's the 10th figure. So that would be 22. 24. Write a variable n. All right, so I'm going to use my expression. All right, so I say the first term, which is 4 plus the common difference, which is 2, n minus 1. And then what's the 20th figure? 20th figure is 4 plus 2 times 20 minus 1. That is 4 plus 2 times 19, which is 4 plus 38, which is 42. All right. Homework is 26 through 29. Homework is 26 through 29.